Chemistry 51 Group Project, presented by Elizabeth Ramirez and Hyoi Kim. Group 7 Elements. Halogens are the group 7 elements that are placed in the vertical column second from the right in the periodic table. They are fluorine, chlorine, bromine, iodine, astatine, and tennessine. Halogens are known for their low melting and boiling points, high electronegativities, and are rarely soluble in water. They react with metals to produce salts of similar properties. They all form acids when combined with hydrogen. Moreover, halogens are highly reactive and were used as poisonous gas during World War I by combining chlorine with hydrochloric acid. The periodic table shown in the right corner highlights the halogen group.
Uses in everyday life. Because they are highly reactive, free halogen elements are not found in nature. In today's world, halogens can be found in everyday life. Halogens are fairly toxic. However, small amounts are needed for human health and life. Fluorine is used in the manufacturing of toothpaste. This helps to protect teeth. Chlorine is used for the purification of water. Most people use them in their pools. Bromine is used in the production of photographic film. And iodine plays a key role in thyroid health as well as astatine. As for tennessine, it is the second heaviest known element and it was discovered in 2010, which makes it the most recently discovered element as of 2022. It is an artificially produced element and it is radioactive, meaning it decays very quickly. So much is still not known about it. Unlike other halogens in the group, tennessine is only used for research purposes at the moment.
Physical properties. As mentioned before, halogens are known to have low melting points and low boiling points, and that is also a sign of property of nonmetals. They are poisonous. Fluorine and chlorines are gases, while bromine is liquid, and iodine and acetines are solid. The color of each element gets darker as you descend the group. The right corner is the indicator of melting points and boiling points of each element in halogen group.
Chemical properties. Halogens are diatomic, meaning that when they are free elements, they are found as two of the same halogen atoms together. They are stable this way. All halogens are oxidizing agents because they are an electron acceptor. They can combine with other elements to form compounds known as halides, namely fluorides, chlorides, bromides, iodides, and astatides. They have high electronegativity, meaning they strongly attract an electron. This means they are also highly reactive.
Number of valence electrons. The halogen atoms carry 7 valence electrons in their outermost electron shell. These 7 outermost electrons are in 2 different kinds of orbitals, designated S with 2 electrons and P with 5. Potentially, a halogen atoms could hold 1 more electron in a p orbital, which would give the resulting Halides ion the same arrangement configuration as that of noble.
Covalent and ionic bonds. Halogens form covalent bonds with nonmetals and ionic bonds with metals. They form ions with a -1 charge because they gain an electron. When they react with metals, they form salts. They form covalent bonds by sharing a pair of electrons. A more reactive halogen can displace a less reactive one from an aqueous solution of halide salts. For example, fluorine will displace chlorine because it is more reactive, and chlorine will displace bromine, and so on. If a fluoride is mixed with chlorine, no reaction will occur because fluoride is more reactive. The figure shows a chemical reaction of an ionic bond. As you can see, the sodium has given an electron to chlorine, and it now has 8 electrons.
Electron configuration. Halogens all have the general electron configuration, ns2, np5, as shown in the figure, giving them 7 valence electrons. They are 1 electron short of having the full outer s and p sublevel, which makes them very reactive. As shown in the previous slide, 7 valence electrons will try to take 1 more electron to complete.
Reactivity decreases as you go down the group because the atomic radius increases as more shells are filled. When the radius is small, the closer the nucleus is to obtain an ion or atom from another element to remove an electron from them. Fluorine has the smallest radius, which is why it is the most reactive. Another reason reactivity decreases is that shielding increases. The more filled electron shells there are between the nucleus and another atom, it is less easily able to attract an electron from them. Because of this, oxidizing power also decreases as you move down the group.
Halogens are diatomic for the most part, except astatine is the only halogen that is not diatomic molecule due to the spin-orbit coupling contribution of relativistic effects that would prevent the formation of the diatomic molecules in solid astatine. All halogens are short of 1 electron to complete the octet. Because of this reason, halogen has a strong tendency to share its unpaired electron with another atom of the same halogen to be complete and hence form diatomic molecules. They form single nonpolar bond. In its element form, it is diatomic. However, because they are so reactive, free halogen elements are not found in nature.
Why do diatomic molecules exist? There are only 7 elements that are diatomic. Other than halogens, hydrogen, nitrogen, and oxygen are diatomic. Diatomic elements exist because of an element's need to achieve stable electron configuration. This means that these elements need to complete an octet to be stable. The figure shows how a halogen gains stable electron configuration with itself. As you can see, they form a single bond by sharing an electron with each other. This is how and why diatomic molecules form and exist.
To sum up our presentation about halogen, they all form acids when combined with hydrogen. They are all fairly toxic. They easily combine with metals to form salts. They have 7 valence electrons in their outer shell. They are highly reactive and electronegative. They all exist as diatomic molecules, 2 atoms, when in their pure form. And that will be the end of this presentation. Thank you so much for watching.